my name is Charlie. I'm a DevOps engineer at Hiro. And what that means is that part of my responsibility is to make sure that Hiro's services stay healthy, they're quick to respond, and what they return is consistent data-wise. So what I'm going to be covering is sort of Hiro's journey, their iterative journey since the Stack's launch of last year, of scaling the blockchain to meet traffic needs. So first, for those unfamiliar with it, let's cover what exactly does the Stacks blockchain API do. It provides data about the Stacks blockchain. So some types of data could be like the accounts, transactions of an account, smart contracts, proof of transfer cycles, NFT data, fungible token data, really like anything about the blockchain itself as far as data goes. It also allows you to submit new transactions to the Stacks blockchain. So it's sort of like the gateway for a lot of developers that are looking to make new transactions or for your wallet, for example. So we're going to cover the API architecture really quick. It's pretty simple. So you have the Stacks blockchain API right dab in the center, and apps will communicate with it by sending web requests. And depending on the type of request, it will either get routed to a backend Stacks node. That's a node that's actually contributing on the blockchain itself. And the Stacks node will respond, and that response will get forwarded to the app. And when I say app, it could mean like a developer that's interacting with the blockchain. It could be the Hiro Explorer. It could be your wallet. It could be really anything that needs to leverage the APIs. If the request is another type that's /extended on the HTTP path, that request will be sent to the backend database, and data will be retrieved from there, which will be forwarded back to the originating app. So what we try to optimize for at Hiro is a high amount of availability. That means that whenever you try to access the API, you can be pretty confident that it will respond at all. So we strive for 99.9% availability. We strive for reliability. That means that the data that's being fetched from the API will be the same on every refresh in your browser or every time that you open up your wallet. And of course, for response time. So what this means is that whenever you use your wallet or you access the Hiro Explorer, you're going to get a quick, snappy response from the API, which will fetter back down to the application that you're using. Same goes with developers that are interacting with the API directly. So, all right. So some of the metrics that we see today are we're actually seeing a 99.97% of availability. So I originally said that we're striving for 99.9%, so we are meeting and exceeding that. Hopefully to get 4 nines very soon. We're servicing over 400 million requests per month, which is ecstatic because when the Stacks blockchain was launched last year, we were not even like a few million requests a month. So it is exceeded our growth expectations quite a bit. And also the response time for many common endpoints is so fast. It's about 50 milliseconds for many common endpoints, like if you're trying to query for transactions. So this is, of course, dependent geographically sometimes. So this is what the architecture sort of looked like on launch day. So we had just a really basic setup that was good for just low traffic at launch. We had one Postgres database, one Stacks blockchain node, and one API that was servicing requests. So what's nice about this is that it allowed us to launch pretty much immediately And also, there were tolerable response times for the low amount of traffic that we were seeing back then. So essentially, like it met the mark and allowed us to focus on improvements to the API going forward since then. However, upgrades were pretty painful in this case. In order to upgrade, it required at times, sometimes a half an hour of downtime or even over an hour of downtime. So during that, the Explorer would not work, wallets would not work. This is like very early days for the V2 launch. Maybe like within the first week, this is kind of how it was. So I switched to what's called blue-green architecture. So if you're not familiar with that, what that means is that we actually have two separate deployments of the API. And we just label them blue or green, but you could call them A or B or 1 or 2. It doesn't really matter so much. But essentially, traffic is only live to one of the environments at a time. So in this picture, we have traffic live to just the blue environment through a reverse proxy. So the API would service requests in the blue environment. And if we needed to upgrade that environment, we would be able to switch traffic to green, upgrade blue, and then switch traffic back when needed. So it allowed for a seamless user experience, essentially. Allowed for seamless API upgrades and protection against downtime. However, this was only good for a short amount of time because traffic still continues to grow. And what we were seeing is that the V2 response time was slowed with increased traffic. So any requests going to the Stacks nodes on the back end were getting pretty slow with increased traffic. And there was contention over resources. So the Stacks blockchain node, for those that are unfamiliar, it is not only servicing back-end requests, but it is also participating in the blockchain, and any events that it comes across, it has to forward them to the API. So in other words, it's doing two jobs here, and both could be pretty stressful. So basically, those two jobs mean that the Stacks blockchain node is going to be fighting over memory and CPU resources. So in order to combat that, we introduced Proxy Pools. So this was a feature upgrade of the API. And what this allowed is that now you're able to have a Stacks node that is dedicated to following the blockchain and sending events to the API. But you also have a separate Stacks node pool, which is a separate address for servicing backend requests on the /v2 endpoint, okay? So this resulted in less resource contention, significantly improved V2 response times, and seamless Stacks node upgrades as well. However, as you can imagine, extended V1 response times were still slowing with increased traffic. So this would be response times of the API accessing the Postgres database. So we did something about that. It's getting a bit more complex here, and I will talk about that in a moment. But essentially, we expanded. We had multiple APIs deployed in the blue environment, and green was very similar, but it's not shown in this photo. But essentially, we had multiple APIs deployed at this point. This was like sometime maybe like July of last year. And each API had its own dedicated database. So traffic was coming into this, to these multiple APIs. You could have 2, 3, 4, 5, as many as you want to service the traffic needs. And each one would have its own database. And each one would have its own Stacks node broadcasting events to its corresponding API. So like, as you can see, this is getting pretty complex, but it met the needs. It allowed us to scale up for the short term. And response times on the extended V1 endpoint drastically decreased, which is awesome. This also improved availability because if one of the APIs became unavailable for any reason, let's say there was like data corruption in this database, for example, the other APIs were still able to service requests. So this increased availability per environment as well. However, like I said, this multiple database per environment thing, this is very complex. So this means that whenever we wanted to upgrade an environment, we had to upgrade each API in the environment and each Postgres database for that API. And it was very unwieldy and just cumbersome in general. Also, any requests coming in being load balanced by these APIs, sometimes the APIs are receiving events in different time because they each have their own Stacks node broadcaster with its own unique mempool, view. So in other words, sometimes if you refresh the browser, you would get different data being returned. So that was a decrease in like data reliability, where sometimes you could refresh the Explorer and you'll see one transaction list appear, refresh, completely different transaction list appear, and it would get settled over time, but it could be really, really confusing for a user experience point of view. And also, you could be left with unused Stacks nodes in the Stacks node pool. So if you think of it like the blue environment is active right now, then green environment, you might be able, you might have some of those services running right there, but they're not being used. So it could essentially be looked at as wasted money, waiting for traffic to be switched to it. So you have some unused Stacks nodes and sort of wasted money at points. So one of the features that was introduced at this point was caching support. This was a huge boon for the API. And what this means is that you can create a file called .proxycachecontrol.json, and the API would pick it up, and in that file, you would be able to specify certain URLs that you could customize what's called the cache control, which is an HTTP header. And essentially, this would allow you to set up a caching mechanism to improve response times on the V2 endpoint. So this is what Hiro uses today. We highly encourage anyone running an API to use this for their setup as well. You will see a huge improvement on V2 response times. Also, you'll get some resiliency to cyber threats because if you have like a distributed denial of service attack where someone sends you like a flurry of requests within a short amount of time, it's not all on the API to respond to that. Whatever the caching layer that you're using would be able to take some of that load off of you. And also, however, traffic did continue to grow for Hiro. And so this is sort of like a balance. Like we implement one improvement, but as traffic grows, we're celebrating, but sometimes response times slow as well. So it calls for a different kind of solution or approach. So at this point, scaling the API was still very arduous and delayed. Whenever a new release would come out, sometimes we would have to, it would take like upwards of a week or longer to actually deploy that on Hiro's infrastructure. So what we were able to implement next is read-only APIs. So this is a feature of the API implemented by Matt and Raphael. So what we have here is we have a split between the API. There's two APIs now. There's a writer API and a read-only API. So the writer does not receive any internet traffic. It has one job. Its job is to receive events from the Stacks node broadcaster and then write them to the Postgres database. Okay? However, the read-only API is able to scale up and down. It can be deployed, as many as you want can be deployed because they're all reading from the same database. So this allowed us to have automated scaling at Hiro that could respond to traffic. So as traffic increased, the number of APIs that we're hosting would automatically increase as well. This reduced complexity because now you're able to get back to just one database per deployment since they're all reading from the same database now. And of course, transitively, you would get better data reliability because one database would mean on each refresh, you're getting the same data every time. And also, because you're now able to scale in response to traffic, you would have much faster response times. However, with so many APIs now reaching out to this Postgres database, if traffic continues to increase, the bottleneck now moves to the database itself. You could have resource contention in the database layer under high traffic. So, database read replicas. So this is similar to read-only mode for the API. However, the API now has support for database read replicas. And what this means is that the Postgres database will now have one primary database that is receiving write events and writing to itself. And then you could have as many number of replicas which are sort of following the primary, and they have an identical replica of all the data, and they're synced with a very, very low sync time between the two. So you essentially now have a database that could scale with the APIs that scale. So this would improve availability, response times, of course, maintaining data reliability, because instead of 3 or 4 or 5 different databases with slightly different views of data, you could have as many databases as you want, and they all have the exact same data view. And of course, the database can scale when needed. You could either add more replicas or remove replicas as traffic increases or decreases. So another really cool thing that was introduced to the API fairly recently is advanced caching. So I'm going to do my best to explain this, Raphael. But essentially, the API would keep track of the block tip in the Stacks blockchain. And so if it sees that the chain tip is at like block 40,000, for example, it's going to keep track of that and send the same data every time until there's a new advancement in the blockchain. So this way, the API doesn't always need to reach out to the Postgres database on every single request. If the Stacks tip has not changed since the previous request, then the Stacks blockchain API will be able to send a much smaller response telling the caching layer to just send back the same thing that you sent on the last request. We also implemented rate limiting. So if anyone attempts to conduct a DDoS attack on the API, they will be immediately rate limited. So this will improve overall availability. And of course, we implemented cyber threat mitigation. So if anyone tries to access like a malicious URL or conduct some unexpected activity on the Stacks blockchain API, then they'll immediately be denied access. So what is next? Well, first, where we started off at the Stacks blockchain launch, since then, Proxy Pools have been implemented, so there's support for that in the API. The API now supports read-only mode as well, and database read replicas. So these are all amazing improvements. Where we are currently, the current set of improvements that are being worked on are SQL query performance improvements, as well as like SQL index improvements, so that whenever data gets fetched from the Postgres database, it will spend fewer cycles looking for the data and come back with a response much faster. Event replay optimization, so that whenever there's a large upgrade for the Stacks blockchain API, it's able to get back up to working mode much quicker and improve CPU performance. so that whenever the API is connecting to the Postgres database on the back end or responding to requests, it does it much more efficiently. We're also looking into microservices. So the API has a lot of jobs right now. It's more than just like a proxy that's sending requests. It's performing a lot of data logic and processing on its end. And as the blockchain gets more advanced, so will the API. So microservices are being looked at as a potential next step to separate concerns. So this would allow you to scale in different sections. So if the API is separated into smaller bits, then you could then if you want, you could scale up on just the pieces that you care about, or only the pieces that need to scale up, while you could save on costs in other areas that don't necessarily need to. Right now, the API is sort of all-inclusive. So if you scale up, you need to scale up the entire API itself. This would also help with availability and resiliency, and in general just make itself more of a cloud-native application. We're also looking at reducing deployment friction. So what this means is making it easier for developers or entities to run their own API. So we're going to be looking at what's called like push-button deployments, essentially where developers can either run a single line of in their CLI, or push like a button somewhere on a site and launch their own API. They would have intuitive and guided setup, as well as the life cycle of the API would be much easier to manage. So these aren't necessarily commitments, but they are ideas that Hiro is looking into. And of course, if you want to accelerate any of this, feel free to contribute directly to the Stacks API. So this link will bring you to a page on Hiro's site to help with show you some resources that you could reference for documentation, bring you to the GitHub repository. Feel free to submit any issues or ideas to the repository as well. And thank you very much. Happy to give this presentation.